Consider the experiment of picking a card from a standard deck of cards. Find the probability that the card selected is ... By part B, everyone should be experiencing a faint pounding in their head. These are headache-inducing. That's why we're going to do a bunch of examples. It's going to be okay. Part A, a face card, given that is a red card. In a conditional probability, you want to look for the word given. Check. Whatever is the condition, that's your denominator. So the given goes in the denominator. Very good. You understand my write that down voice. The given goes in the denominator. So part A, face card, given that it is a red card. How many red cards are there in a standard deck of cards? 26. Out of those 26, how many are face cards? 6, because you have your Jack, Queen, King of Hearts, Jack, Queen, King of Diamonds. So 6, 26, or reduced 3/13. I'm going to move that over a little bit. That's better.
You said 26 are red cards.
Correct. So the denominator represents the number of red cards. Let me write this in. So, number of red cards. The numerator represents the number of face cards that are red. In other words, the intersection.
But aren't you still picking from a 52-card deck?
You are picking from a 52-card deck, but it's just like you picked a card, and I tell you, okay, you picked a face card. Now what are the chances that it's a red card? Or excuse me, you picked a red card. Now what are the chances that it's a face card? Well, right, we'd have to separate it by the reds because that's the condition.
Yeah.
Correct. So typically when you put a condition on it, it may increase your probability depending on the problem. So we're not talking about all 52 cards now. We're only talking about those that satisfy the condition. Part B is tasty. Part B, a red card, given that it is a face card. Well, a lot of students like to take the answer to part A and put the reciprocal 26/6. But that's like saying the chance of rain is 400%. Can your numerator be bigger than your denominator? No, so don't ever do that. That's bad. Correct. So let's start with the denominator. How many face cards are there? 12. Out of those 12 face cards, how many are red? 6. Which is 1/2. So in English, the 12 represents the number of face cards. The 6 represents the number of red cards that are face cards. Oh, I changed the thickness of the green. What are you going to do? Bada bing. Is the 6 in the numerator part A different from the 6 of the numerator in part B? One of you is correct? No. We're talking about the same 6 cards. This says face cards that are also red. This says red cards that are also face cards. Is peanut butter and jelly the same as jelly and peanut butter?
No.
Yes, except as everyone knows, I don't know if we had this discussion, you always put the peanut butter first. Otherwise, you'll get little jelly crusties in your peanut butter, and that's gross. Sherry, do you know what I'm talking about? It's gross, isn't it? Yeah. You spread the peanut butter first, and then use that knife for the jelly. If you go the other way around, you get little jelly crusties. It's really gross.
Yeah, exactly.
No, that's just go. If you live by yourself, it doesn't matter. If you just pour it right by on top, it's fine. All right, now that we've had that spirited discussion. So again, your given is always your denominator. So part C, a club given that it's at 4. So how many 4s are there? 4. Out of those 4 4s, how many are also clubs? 1. Part D, a 4 given that it is a club. So the given's the denominator. How many clubs are there? 13. Throw in your voice. Very good. Out of those 13 clubs, how many are also 4s? 1. E, the 4 of clubs. 1 out of 52. There's no given here. But the 1 in part C, part D, and part E all refer to the 4 of clubs. You're just taking it from different viewpoints. In part C, from the viewpoint of 4s, D's from the viewpoint of clubs, and E from the viewpoint of all cards.